Well, it's time to turn the corner. And when we turn the corner, we move from series of numbers to series of variables. This is sort of the thing that math does. Your mathematical development moved you from numbers to variables, and that's what we do here. Let's talk about what we mean by a power series about x equals a. It's a series of the form sum as n goes from 0 to infinity. Notice that that's a 0 to infinity of some number times x minus a to the n. And what that means is if n equals 0, then this is a constant. It's just the constant term. And if n equal, oh, it's not c sub 0, c sub n. So sorry. Plus, if n is 1, there's some number times x minus a to the first. And if n is 2, there's some number times x minus a squared. And it just keeps going. It's like a polynomial, but it doesn't stop. Can't stop, won't stop. The number a is called the center for reasons that will be clear. And all of these c sub i's are real numbers. So this takes us back to that time in Calc 1 when we said, gosh, if everything could be a polynomial, life would be so much easier. Polynomials are easy to work with. This thing is a polynomial that just keeps coming at you. So what does that look like? On what interval of x values does 1 plus x squared plus x cubed plus dot dot dot, the nth term is x to the n plus dot dot dot, converge? On what interval of x values does that converge? Well, let's think about what kind of series this is. This is a kind of series we have studied before. It is geometric. Multiply by x, multiply by x, multiply by x, and so on. So the sum of the series is the first term divided by 1 minus r, right? So 1 plus x squared plus x cubed plus dot 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 is 1 over 1 minus x on the interval of convergence. On the interval of convergence. But what is that interval of convergence? Well, this is a geometric series, and we know that geometric series converge if the absolute value of the ratio is less than 1. Well, the ratio is x, so the interval of convergence is where the absolute value of x is less than 1. That's negative 1 to 1. But what does that really mean? Well, this is 1 over 1 minus x. If we were to graph 1 plus x squared plus x cubed, well, this red curve snuggles up pretty close to the blue curve in this area and not so much outside. And if we were to add more terms, we would find that the black curve snuggles up closer to the blue curve for longer. And Oh, we could, I won't do this too much, right? Like you don't just want to watch me make functions. Right? It looks like all of these curves, the red one, the black one, the purple one, they all snuggle up to the blue one better and better and better, but not outside of a window. Well, where's the window? The window is between -1 and 1. That's where the window is. So if we were to narrow things down here and take a look in the window, we would see that between -1, -1's about here, and 1, 1's about here, the more terms you add on, the closer you get to the blue curve. The blue curve is the limit of all of the other curves as we add more and more terms. That's what it means to say that a power series converges. It means that there is some function that describes the limit as you add more and more and more and more terms. And within the interval of convergence, the more terms you add, the better you do approximating. So there are three possibilities for intervals of convergence. There are three possible intervals of convergence. Okay? Sometimes the interval of convergence goes from the center to some value on its left, and then up to a point from the center to some value on its right. The R is called the radius of convergence for reasons that are fairly straightforward. This happens if rho is less than 1 sometimes. And if rho is less than 1 sometimes, you get an interval like this, like in our case, -1 to 1. And in this case, we have to check the endpoints to see if there is convergence at the endpoints. Now, in our case over here, we know that because it's a geometric series, there is no convergence at -1. There is no convergence at +1. And that's pretty straightforward. 1 plus 1 plus 1 plus 1 plus 1 doesn't converge. The second possibility is that the interval of convergence runs through the number line from -infinity to infinity. This happens if rho is less than 1 always. And then the third possibility is that the only place where there is convergence is at x equals a. And this happens if rho is greater than 1 for all x. There has to be convergence at the center. Sometimes there's convergence everywhere. Sometimes there's convergence on a finite interval that's centered at a. Those are the only three possibilities. Other videos will help us to use the ratio test to determine what those intervals are, but for now, this is sufficient. Okay, thanks.